you run out of time on the SAT math because you don't know the fastest ways to solve the hardest questions. Last week, Sonia, one of my students, took the SAT and finished the second math module with 12 minutes to spare. Sonia, how much time did you have left at the end of module 2?
I had actually 12 minutes at the end. I think before I would always run out of time on maybe like the last like 3 questions, like the harder geometry ones. I never really finished a mod on time. I think I would always walk out of the SAT with like a few like missed ones. But this time after we like drilled so many problems, I just recognized like every single one that came up on the test, and I just had so much time left because I already knew how to do everything.
I'm going to show you exactly how to do what she did by helping you find the fastest solutions to 10 of the hardest SAT math questions that you'll probably see on your next test. Let's go to the whiteboard. Here is how we're going to find the fastest solutions to each of these questions. We're first going to identify what type of question this is. This is important because if we have these solutions almost memorized, because we've seen so many of these questions, we'll be able to act on the solution very quickly without even need to think. The goal is not to think about these solutions and have them almost memorized. So anytime you see 90 minus x, whether it's cosine 90 minus x or sine 90 minus x in a question, you always think of this trig identity, that sine x is equal to cosine 90 minus x. And the same is true for the opposite. So this is definitely worth memorizing, but I'm going to show you how to think about this in a much simpler way. If you see cosine 90 minus x, what you want to replace this with, turn the cosine into a sine, and then take whatever variable is right here and just place it down here. So cosine 90 minus x turns into sine x. Same thing here. Turn the sine into a cosine. So flip whatever this is from sine to cosine and cosine to sine, and then take whatever variable is right here. Cosine x. Now, before we move on, let's do a little more practice. So what is sine 90 minus h? Cosine h, right? Because you just flip this and you take this variable down here. Let's do another one. Cosine 90 minus p, what is this? Sine, because you flip this, then you take this, p. You just need to memorize that, that's all. Now, let's add back the rest of this. So sine x. Okay. And you might be saying, well, Roy, what do I even do from here? This doesn't help me out. From here, just treat these as variables. So pretend sine x is equal to a. If you see a times a, what does that simplify to? A squared, right? So sine x times sine x is just sine squared x plus cosine squared x. And I think that you might see it, but sine squared x plus cosine squared x is the famous identity. This is equal to 1. If you've taken a digital SAT recently, go ahead and message me the hardest question from your test on Instagram at resolveroy._. I know you have it saved somewhere, so just message me that question, because these videos take me a long time to make for only one reason, because I have to find real past digital SAT questions, and they're not publicly accessible online, to model my questions off of. So all of these questions that you see in these videos are modeled off of real past digital SAT questions. If you guys could help me out and actually send me the questions that you've seen, I can make videos on them, meaning I can make higher quality videos faster. So just please help me out. Thank you. Let's move on. Let's find the fastest way to solve this. A circle in the xy plane has a diameter with endpoints -15k and ak, where a and k are constants. An equation of this circle is x plus 7 squared plus y minus k squared equals r squared, where r is a positive constant. What is the value of a? If your first instinct was to put this into Desmos, you would be correct. And notice how I'm just keeping all of the variables. So k and r. The second thing that we do is we also graph the point -15, comma k. And the reason why we're doing this is because we want to adjust the value of r until this purple point is on the graph. Why do we want to do that? Well, it seems that when r is 8, -15k is on, let me write that a little better. -15k is on the graph. And that makes sense because it's an endpoint of a diameter, and endpoints on the diameter are on the circle. Okay. And you'll see that for any value of k, this works. -15k is still on the circle. Okay, what do we do from here? Well, since we're looking for the other endpoint, we can simply place our cursor along this circle and it snaps into place. Do you see how it snaps into place at the other endpoint? Desmos always does this. So the other point is 1, 6. And you can see that for any value of k, let's set k equal to, I don't know, 7. I think we had 6 last time. Yeah. So it's 1, 7. So for any value, it's always going to be 1, k, right? Because this other endpoint is a, k. So we don't care about the y value, we only care about the x value. And the x value is always 1. So a is going to be equal to 1. So if you're having a hard time visualizing what the question is asking, just graph it. Especially if you get points, especially if you get a function, you can always add a slider for the variables. By the way, if for some reason Desmos isn't giving you an option to add a slider, just set k equal to 5 or the variable that you want to add a slider for, and then you get a slider. Don't set k equal to 0 or 1. In the given equation, k is a constant. The equation has exactly one real solution. What is the value of k? All right. If your first instinct was to do this on Desmos, you would be wrong. We do not do this on Desmos. And the reason why is because anytime we're given like the equation has one solution and we're given an equation like this, Desmos, you know what? Let me just show you. Desmos makes it really hard to see. And they do this on purpose so that it's not very easy to just find a solution by graphing it. 5k. And then let's add a slider for k, right? But then what we're going to see is that as we keep adjusting k, first of all, we have to adjust the scale, which I've seen so many students waste so much time on. But if you're not good at using the scale, it's just going to be really hard to just keep zooming in until there's only one solution. The point is, don't do it this way. Here's the shortcut that I'm going to show you. And it's by doing it by hand. So ignore all of this right now. Let's go back to the question. Anytime you see the number of solutions on an SAT question, it's always either one of two different types of questions. This is something you should definitely write down. Anytime you see the number of solutions, it's either a discriminant question or you're setting the slopes of two lines equal to each other. Always. So for example, in this question right here, let's take a look at this function because the right side is the first function. 40x plus 5k, well, that's a line. right? Because 40 is the slope, 5k is the y-intercept. Let's look at the left side. What function is that? There's an x squared, so that means it's a quadratic. So we cannot set these slopes equal to each other because a quadratic doesn't have a slope. We have to use discriminant. Do you see how this works? So do this anytime you see the number of solutions on an SAT question. You're either going to use it to the discriminant or the slope. Memorize this. So we just figured out that this is a discriminant question. What do we do in discriminant questions? Well, we have to bring everything to one side in standard form. What is standard form? Ax squared plus bx plus c. That's the standard form of a parabola. So we have to make it look like this. And that's pretty simple for this type of question because we just move everything over. To one side. Okay. And now we are going to use the discriminant b squared minus 4ac. First of all, let's write this out. And what do we do to the right side? Because the discriminant is always either equal to 0, greater than, less than, something like that. Well, since this equation has exactly one solution, it's going to be equal to. If it has two solutions, it's going to be greater than. If it has no solutions, it's going to be less than 0. This is also something that you need to memorize because the SAT is going to test this in different ways. B squared minus 4ac is equal to 0. And what we can do is we can actually just put this into Desmos. Since we know that b is negative 40, so b squared minus 4 times a, which is 4, times c. Here's the tricky part. C is not negative 5k. C is also not 20. It's this entire thing. Okay. And then this you set equal to 0. And since when there's an equal sign, Desmos only likes x and y, you just replace the k with an x temporarily. We zoom out. X equals negative 16, which in this case is really k. Right? So we solved for the right variable. We solved for k. Perfect. I want you to do these questions this way. Don't do it on Desmos. Like, don't graph this onto Desmos like we did at the beginning. Do it this way. And then once you get to this part, the discriminant part, then put it into Desmos, right? Okay, let's move on. The given equation relates a, b, and c where a, b, and c are greater than 1. Which equation correctly expresses a in terms of b and c? Part of finding the fastest solutions to each of these SAT questions, each of these hard SAT questions, is really just taking the entire text that you just read and simplifying it into the fewest words possible. So if I were to do that for this question, I would simply say that this is just asking us to isolate for A. That's it. We want to take this equation and isolate for A. It's a lot simpler when you do it that way, right? So anytime you're given a bunch of variables in an equation and you are told to isolate for a single variable, what I want you to do is ignore the variable that you want to isolate for now, and only focus on combining the two fractions. Whatever fractions there are, whenever you're isolating for a certain variable, just combine them first. So how do we combine these two fractions? We need a common denominator. The common denominator between a and bc is abc. Okay. 7 over a times bc over bc. Now, if you're confused on why I'm doing BC over BC and A over A, it's just like 1/2 plus 1/3. The common denominator here is 6, right? So we multiply by 3 over 3 and then 2 over 2. And then once we do that, we get 3 over 6 plus 2 over 6, which is equal to 5 over 6. It's the same idea here. We want to multiply by BC over BC and A over A. So we get the common denominator of ABC on both of these fractions. Okay. And then this is all equal to 4. Make sure you don't drop this part. I almost did. 7BC over ABC plus 8A over ABC equals 4. 7BC plus 8A ABC equals 4. Okay, what I'm going to do is I'm going to erase all of this right now because we need more space. All right. And you might be asking, Roy, what do we even do from here? Here is what we do. Let's multiply the ABC to the other side. So once you've combined the two fractions, right? Since you're isolating for a variable, you always combine the fractions. And then once you've combined the fractions, you multiply the denominator to the other side. 7BC plus 8A equals 4ABC. And from here, since you're solving for A, now this is when we look at the variable that we're solving for. So let's move the 8A to the other side by subtracting by 8A. 7BC equals 4ABC minus 8A. And then let's factor out an A. That's all we want to factor out, just the A. 4BC minus 8. The reason why is because we can divide 4BC minus 8, 4BC minus 8 to the other side. And what we end up with is 7BC over 4BC minus 8 equals A. Okay, let's move on. A square is inscribed in a circle with the equation x squared plus y squared minus 6x plus 8y equals 17.25. What is the area of the square? Whenever you see this on an SAT question, there's 3 points. What do I mean? This. It's the equation of a circle. So first, let's draw this out since it's a geometry question. Always draw it out. A square, that looks more like a rectangle, is inscribed in a circle. Oh, I guess it is a square. I don't know. So make sure you know what is inscribed in what. I've seen a lot of students mess up here, even though they know what inscribed means. They just see this as the first shape and they put it outside. Don't do that. Okay, so this is the equation. What is the area of the square? Well, let's work backwards from what we're solving for. Area of the square is equal to side squared, right? So if we have one side of a square, we can find the area because it's just the side squared. Now, why don't we know what the side is? Well, what do we need to know to find the side? If we knew the diagonal of the square, we would be able to find the side because the diagonal is equal to s root 2. Why? Because if you cut a square in half, it turns into a 45, 45, 90 triangle, meaning the hypotenuse is going to be s root 2. These special triangles are on your SAT reference sheet, but you should also just memorize them, right? Because it just saves you time. This entire video is about saving time. So memorize them. Now, the diagonal of the square is also the diameter of the circle. So if we take a look at this and we find the diameter of the circle, we will have found s root 2, which then Finding s squared is pretty easy from there. All right. Here's how we do it, and here's why these are free points. Because you don't have to complete the square here. On the SAT, whenever you're given an equation of a circle, you can always just graph it like this, and then the top and bottommost points are always graphed. So then export each of these points like that. Set one of them equal to a variable like a. I always do a and b. Do the other one equal to b, and then find the distance between them by doing distance, open parentheses, a comma b. And Desmos will find the distance for you. And I think that you can see that 13, which is the distance right here, says it right here. It's the diameter of the circle, right? So the diameter is equal to 13. The diameter is also equal to s root 2. So that's equal to 13. Now, what we can do here, s square root 2 is equal to 13. We just replace this with a tilde, and it gives us the value of s. Now, why did this work? Because anytime you have a variable other than x or y, you have to use tilde. You can't use the equal sign. Basically, the tilde replaces the equal sign. Okay. And since we're solving for the area, we need s squared. So literally just type s squared. 84.5. So yeah, the fastest way to do this question is to recognize that anytime you're given the equation of a circle, it's just free points because you can do a lot of it on Desmos. Just make sure you're drawing it out by hand, please, right? These geometry questions, I've seen so many students get these geometry questions wrong because they don't instinctually just draw it out by hand at the start. Make it a habit. If a particular can of dog food has a volume of 84.12 cubic inches, what is the volume of this can of dog food to the nearest whole number in cubic centimeters? 1 inch equals 2.54 centimeters. All right. Anytime you see a unit conversion, it's a unit conversion question. You don't even need to think about how do I solve this? Just immediately jump into dimensional analysis. If you learned it in chemistry or physics, then just do it, right? So here is what we need to do for this question. Cubic inches is the same thing as inches cubed, the same exact thing. Now, since we want to convert this inches cubed into centimeters cubed, all we need to do is we need to multiply 2.54 centimeters over 1 inch. Why did we do this? Because this fraction is actually just 1 over 1. Why is it 1 over 1? Because the numerator and denominator are the exact same, right? 1 inch is equal to 2.54 centimeters. All right. 1 over 1 is equal to 1. So this fraction is basically equal to 1. We are not changing anything about, technically, we're not changing anything about the number here. We're only changing the units, which is what we want. The problem is that there's an inches cubed here, and this inches here is not compatible. We need inches cubed down here, so we can have inches cubed. So like the inches cubed can cancel out. So we can take all of this and cube it. Why? Because if we take 1 over 1 cubed, it's still 1 cubed over 1 cubed, which is equal to 1 over 1, which is equal to 1. So we're still keeping all of this as 1. 84.12 inches cubed times. And then this 3 distributes everywhere. Make sure you're doing that. Okay, perfect. Now, anytime you see units, think of it as like a variable. So if inches were x, then inches cubed is x cubed. If you see an x cubed in the numerator and also in the denominator, so multiplied by, let's say, y cubed for centimeters cubed over x cubed, these two will just cancel out because there's one in the denominator and in the numerator. So you're only left with y cubed, which is perfect because when we put all the numbers on one side, which is 84.12 times 2.54, these inches cubed cancel out, and then you're left with a centimeters cubed. By the way, this is supposed to be 2.54 cubed, my bad. 84.12 times 2.54 cubed. Make sure that we are reading the question. If you answered 1378.4 0.48, or if you answered 1378.5, you would have gotten this question wrong. 1378 is the correct answer because we're rounding to the nearest whole number, right? Okay, last thing, the hardest part about this question is basically just setting up this fraction. Make sure that we are putting the centimeters at the top. Why do we put the centimeters at the top? Because when we cube everything, the inches cubed is going to be at the bottom. That's the only way that we can cancel the inches cubed at the top if we have an inches cubed at the bottom. 1378, perfect. Let's move on. The vertex of the function f of x is given as 8, -15, and the point 4, -3 lies on the parabola. If g of x equals 5 times f of x minus 3, what is the value of g of 0 minus f of 0? Anytime you see this on the SAT, where you see some function equals some translated function, because this is a translation, right? This is almost always an entirely Desmos solution. You just hop into Desmos and you do all of the work there. So what do we need to do first? Let's work backwards from the problem. The first thing that we need to do to find g of 0 minus f of 0 is find the parts, right? We need to find g of 0, and that we also need to find f of 0. This is how you think through these questions. You first look at what are we trying to solve for, and why can't we immediately solve for it? What do we have missing? So we don't know what g of 0 is, we don't know f of 0 is. Now, how would we know what g of 0 is if we knew what f of x is? So if we know what f of x is, then we can just find what g of x is and plug in 0 to find g of 0. But all of these, g of 0 and f of 0, rely on knowing what f of x is. So let's solve for this. Let's figure out what function this is. Let's first add a table, right? And anytime we're given points, we can just enter them in and then add this regression and switch this from a linear to a quadratic. The reason why it's a quadratic is because it has a vertex and it says it's a parabola. So it graphed the function for us right here. Is that the correct f of x? No, it's not. Why? Because 8, -15 is supposed to be the vertex, and it's obviously not. The vertex is this point right here at the top. Okay. Since we want our graph to look like this, with 8, -15 at the vertex, how do we fix this? There's going to be a point 4, -3 here. right? Let me write that a little better. 4, -3. What we know about parabolas is that they are symmetric along the x-axis of the vertex. So along x equals 8, this parabola is supposed to be symmetric. Let's turn this off so we don't get confused. There should be another point somewhere here because it's symmetric. It mirrors each point. So there has to be another point at the same y value as this point. So there has to be a point at -3. And to figure out the x value, since this is 4 away from the vertex, from 4 to 8, we go another 4 to the right. So this is 12, -3. If we plug in 12, -3, we'll see that now we have the correct parabola. Let's recap on exactly what we just did. So let's erase a little bit. Just to recap, we know that parabolas are symmetric. So if we don't know what this point is right here, we know that there has to be a point on the other side of this line that's at the same y value as this point right here, because parabolas are symmetric. It's symmetric along this line, the line of the vertex, right? So if there has to be another point on this other side right here, it has to be at the same y value of -3, but the x value has to be equidistant from the vertex as this original point. And since this is 4 units away on the x-axis, it has to be another 4 units away to the right, right? Because this point was on the left of the vertex. This has to be on the right of the vertex. Hopefully that makes sense. I call that a mirror point, M-I-R-R-O-R, because it's mirrored on the other side. So we just found our mirror point. It's 12, -3, and Desmos now knows that 8, -15 is the vertex because of our mirror point. And now we have the correct equation. We can just export it and set this equal to f of x. That was the hardest part about this question. So if you were able to figure that out, awesome. Because the next part is much easier. We just set g of x equal to 5 times f of x minus 3. Because it says it right here. And then this part is even easier. G of 0 minus, well, f of 0. That's your answer. Okay. By the way, there's a little thing that I don't think I've mentioned before in a video, but every SAT, you know those like free response boxes where you type your answer in? Every box has only 5 character spaces. So technically this would never be an answer on the SAT because there are just too many spaces here. There's 1, 2, 3, 4, 5, 6 spaces, right? So this wouldn't be an answer on the SAT because it just takes up too much space. But, you know, I wrote these questions. I modeled them off of real past digital SAT questions. So, you know, I did my best, but that's just something to know. The SAT is never going to have this answer on the SAT because it's just too long. But this is the correct answer to this question. In a set of 5 consecutive even integers where the integers are ordered from least to greatest, the first integer is represented by x. The product of 30 and the fifth even integer is at most 54 greater than the sum of the first and third even integers. What is the greatest value of x? You might have this on your next SAT. Like there's a really good chance. It always says like a set of like 5 consecutive even integers or 5 consecutive odd integers. Now it's either, 4 or 5, but typically it's 5. So the first thing we want to do is write out the 5 consecutive even integers. This is the first one, this is the second, this is the third, this is the fourth, and this is the fifth. Now, it does not matter if these are even or odd because they're written the same exact way. X plus 2, x plus 4, x plus 6, x plus 8. Let me give you some examples. So if there are 5 consecutive even integers, then it's going to, let's say, this is an example, right? It doesn't have to be this way, but it could be 2, 4, 6, 8, 10. And they're always spaced out by 2, right? Because consecutive means next to each other. And the number next to 2 is 3, but that's odd. So you have to go one more. So it's x plus 2, x plus 4, right? Same thing if the integers are odd. So 1, 3, 5, 7, and 9. It's still x plus 2, x plus 4, x plus 6, all the way down. Now, if there are only 4 integers, then only write 4 of them. But in this case, it says 5. What you want to do for this question is it's always going to ask you to create an equation using these integers. And it's always going to be an inequality. So it's not going to be an equation. Ignore the inequality for now. Replace the inequality with an equal sign for now. Because students always get confused and like tripped up by the inequality. So just put a placeholder for now, do it at the end. The product of 30 and the fifth even integer. Okay, fifth even integer. Do you see how clear this is? Write out this table on when you actually do this question. Is at most, so just placeholder, put the equal sign here. 54 greater than the sum of the first and third even integers. 54 greater than that. X plus 4. So this is the sum of the first and third even integers. X plus 4. And then you add a 54. This is probably the most confusing part. These words right here. Is at most 54 greater than? What is that? 5 words and a number is the most confusing part about this question, and I get it. Now, is at most represents whatever inequality goes here, but greater than actually represents this plus 54. Now you might be confused. Why doesn't greater than represent a greater than sign? It's because of this word is. Let me give you an example. Let's take a look at these two examples. 5 greater than 2. What does that mean? That means 2 plus 5, which is 7. But what is 5 is greater than 2? 5 is greater than 2 is like this. It's an inequality. The only difference is this word is. If you see this word is, that means this is an inequality. If you don't see the word is, that means it's an operation, like it's plus or minus. For example, if we go up here, if we say 5 less than 2 instead of 5 greater than 2, then this would instead be 2 minus 5. You subtract the 5 at the end, right? Because let's say 5 less than 100 would be 100 minus 5. It wouldn't be 5 minus 100, right? Now that we got that out of the way, let's erase all of this. Let's go back up to this question. So we added the 54 at the end because it's 54 greater than, right? There's no is, so it's just plus 54. But since there is a is over here, it's at most. Now, what does at most mean? If you're having trouble understanding what at most means, just play it out. So let's say A is at most B. Which one is bigger? B. A has to be equal to or less than B. Because A cannot be bigger than B. It's at most B. Okay. Now what? Desmos time. Okay. So we just got, again, write out the inequality. Even though you put it into Desmos, just write it out one more time. X has to be less than or equal to negative 6.5. Now, I know that it's less than or equal to because, first of all, the line is it's not dotted. It's like a solid line, meaning there has to be an equal to because there was an equal to here. And I know that it's less than because all of the numbers in the solution region are less than this original number, negative 6.5. What is the greatest value of x? If you answered negative 7, you would be wrong. It's not negative 7. The greatest value of x is negative 8 because it has to be less than negative 6.5. It has to be an integer, and it also has to be even. That's the trick. It has to be even. So your answer is negative 8. All right, let's move on. For the polynomial function f, the graph of y equals f of x in the xy plane contains the points negative 5, 0, negative 9, 0, 4, 0, and 0, 0. Which of the following must be a factor of f of x? I want you to recognize that anytime you get x-intercepts of a function, these are basically factors. Why? Because you can reverse them into their factors. If I give you the function y equals x minus 3, x plus 2, then what are the factors? I mean, what are the y-intercepts? Fuck, bro. If I told you that y is equal to x plus 3 times x plus 2, then what are the x-intercepts of this question? Well, the x-intercepts are when y is 0, right? X plus 3, x plus 2. And I think that from here, you can just see that x equals negative 3 and negative 2, but that's when y is 0. So then we can write this as an ordered pair as negative 3, 0 and negative 2, 0. So these are our two ordered pairs. There are x-intercepts, right? Which of the following can be a factor of f of x? We can reverse these into their factors. So x plus 5, x plus 9, x minus 4, and x. And for our purposes, this is technically equal to f of x. To solve this question, to find which of these must be a factor, we just multiply two of them. We take any two of these factors and multiply them. And if we get one of these answer choices, then that's the factor, right? So, for example, how do we get 45 at the end? Well, we multiply these two. What is x plus 5 times x plus 9? X squared plus 5x plus 9x plus 45, right? We're just foiling everything out. And then this turns into 14x, which is not the same as negative 13x. So A is not our answer. Let's go on to the next one. How do we get negative 36? Well, we multiply this and this. X plus 9, x minus 4. X squared plus 9x minus 4x minus 36. x squared plus 5x minus 36. That is not 13x, right? Okay. What is next? Did I just delete the entire thing? What is next? Negative 20. How do we get that? This times this. X plus 5 times x minus 4. And I think you're getting the point at this point. You just take two of the factors and multiply them based on how do we get each answer choice. X squared plus 5x minus 4x minus 20. X squared plus x minus 20. And that's not C because this has a minus x. And then this last one, okay, this last one is you take this and this, right? And as you can see, x plus 5 times x, it's just x squared plus 5x, which is your answer. It's D. So let's recap. How did we do this? We reversed each of these factors, or reversed each of these x-intercepts into factors. And then we took factors two at a time and multiplied them to try to equal each of these answer choices. We only found that D works. D is the only one that works. The percent increase in population of a certain ant colony from the beginning of September to the end of November was 1,482%. If the number of ants in this colony was K at the beginning of September, which expression represents the number of ants at the end of November? All right. So the SAT loves to try to throw you off by saying like beginning of September, beginning, end. Don't worry about any of that. Just think September and November. Let's label September as a certain variable. In this case, K is actually equal to September. So we don't need to assign a variable to that. Now, November, let's do N for November. November. Again, the reason why we did K is because there's already a variable for September. The question says that the percent increase in population from September to November was 1,482%. This is tricky because it says the increase right here. So if it says percent increase, you have to take whatever percent it is, in this case, 1,482%, and add 100 to it. That's how you find percent increase. You take the percent and add the original, which is 100% always. Now, once you add these together, you get 1,582%. Anytime you see percent, it's just the number divided by 100. Remember that. Percent is number divided by 100. And as you can see, there's only one answer choice that matches that, right? So if we were to, write this out as an equation, we're basically saying that since n is the bigger one, right? We have to multiply 15.82 to k for it to equal n. So this is technically our equation. N is equal to 15.82k. The only part we really need to find, we don't even need to find this equation. We just need to understand that percent increase is 100% plus the percent. So 100 plus 1,482. Hey, if you've taken a digital SAT recently, go ahead and message me the hardest question from your test on Instagram at resolveroy._. I know you have it saved somewhere, so just message me that question, because these videos take me a long time to make for only one reason, because I have to find real past digital SAT questions, and they're not publicly accessible online, to model my questions off of. So all of these questions that you see in these videos are modeled off of real past digital SAT questions. If you guys could help me out and actually send me the questions that you've seen, I can make videos on them, meaning I can make higher quality videos faster. So just please help me out. Thank you. For any future SATs that you take, I'm rooting for you. Bye-bye.